All right, so our lesson is going to begin, of course, talking about where we left off with the Alchemy of Pennies lecture. We made pennies that we started off with normal copper colored. When we went to a more silver color, then we went to a gold color. We talked about Archimedes. We talked about the possibility of it being brass or gold. We talked about possible tests we could use. But really what this led to is that we could measure the density of our metal, which was the penny, to figure out whether it was gold or brass. So today, I'm actually going to show you two sets of data. And these are actual students that I had in my class about 4 or 5 years ago when I first made this PowerPoint. We've got George over here on the left, and he was trying to figure out whether the penny was gold or not by measuring its density. And he did a bunch of tests, but all of his measurements were done using using a triple beam balance. How many of you have used a triple beam balance before? Yeah, those things they're not as precise as this piece of equipment, which you did use, which is called an analytical balance, which is the equipment that Martha used when measuring her density. So I'm going to have you look up here and answer these questions. Class, who made better measurements, George or Martha? I said class, so you can shout it out, guys.
Martha.
Martha made better measurements. Good. Who has greater uncertainty in their measurements? Who is less sure about what they're recording? George, yeah, see, they're both measuring the same penny, but they measure it in multiple trials. So 1, 2, 3, 4, 5 trials. Let's move on to the next one. Who is more precise, George or Martha?
Martha.
Good. So now we already understand what we need to know about precision and uncertainty. George's measurements are less certain. Why? Because the range of his values when he measures the density for the penny range between 13.6 and 16.2. Martha's range is between 13.9 and 14.1. This plus or minus right here is what we refer to as the uncertainty for your measurements. The lower your uncertainty in a measurement, the higher the precision for that measurement. So this actually becomes really, 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 really important, because if you are trying to tell the difference between brass, this alloy right here, and gold, well, if you look at George's measurements span from here to here. He can't tell whether the penny is actually made of gold or whether it's made of brass because he has such a large range for all the values that he's measuring. Martha's range is really small, so she's able to actually much more conclusively say that that penny is made of brass as opposed to made of gold. So that's a really key concept that we have to work with here. So who is able to identify what the gold penny is? Certainly Martha. This line that goes up and down, we actually refer to as an error bar, and that can represent our uncertainty. All right, so uncertainty is margin of error in our measurement. We're going to be measuring volume a lot in this class, especially for the rocket lab coming up. So we've got a graduated cylinder here, and it's labeled 0 at the bottom and 10 at the top. I'm going to go through a bunch of numbers. So first off, we need to know that these numbers, you got to figure out what increments they go up by. Sometimes they go up by 1, sometimes they go up by 2. Sometimes in our larger graduated cylinders, they go up by 5, 10, or even 100 milliliters for that matter. So it keeps on going up. You got these. So the big lines that have a number on it, those are called major grid lines. All these other ones that I've pointed to here, those are called minor grids, and those are all the ones without the numbers. So how do you make a measurement when it falls between two numbers? We have this volume that's between 5 and 6. Where do we actually make our measurement? Well, this dip that we see in the graduated cylinder, you usually see that dip when you work with equipment like burettes, or you work with equipment like glass graduated cylinders. Usually it's with glass. And the reason is that there's these strong cohesive, or actually I should say adhesive forces between the liquid and the glass. Believe it or not, with mercury, it's the opposite. The mercury is more attracted to itself, so it actually bubbles up. So with water, it goes down like this. You want to make your volume measurement at the bottom of this line right here, and that's called the meniscus. So here's how we have to make our measurement. We know our measurement has to be somewhere between 5 and 6. So since our measurement has to be between 5 and 6, we know at least it's 5 milliliters. At the very minimum, it's 5. But now we have to guess. We got to go, all right, it's about a third of the way to the 6, so we're going to guess 0.3, 5.3. That's a guess, because some of you might have picked 5.2, some of you might have picked 5.4. So, are we certain that it's 0.3 beyond 5? No, not at all. So, what we have to do is we have to take that measurement of 5.3, and we have to know that we have to be able to express our uncertainty. So, at lowest, this volume, at lowest, it's probably 0.2. At highest, it's probably about 0.4. So we know it's between 5.2 and 5.4, and that's a probable range that our volume is. See, we have to write any measurement down in this class with the probable range for our guess. Remember, our guess is that 0.3, and then we have to be honest with ourselves and say, well, it might not be 0.3, it might be 0.2, might be 0.4. So the way you write it out is, of course, with uncertainty. So you have your best estimate, which is the 5.3, and you always want to estimate one digit to the right every single time. And then you write your uncertainty, which expresses your probable range. So if I add 5.3 plus 0.1, I get my 5.4. If I subtract the 0.1, I get the 5.2. Moving on, here we go. So you always have to have a unit in your number. So this is actually one of the test questions that you're going to have on Friday. What does Mr. Barron classify as a good measurement? Anything that has a number, a unit, uncertainty, and description. So what are we measuring? Are we measuring water? Are we measuring mercury? What the heck is it we're measuring? So write this to represent your uncertainty. There you go. That's it. That's all you need to know. What we're going to do now is we are going to practice writing out our uncertainty. So we're going to do this together as a class. And the way we're going to do it is this. I have the worksheet that you are going to be practicing with, and we're going to do these measurement practices together in just a moment. All right, so what we're going to do is we're going to practice labeling what are called the minor grid. Some students make mistakes all the time in figuring out what numbers go up by. We have a lot of glassware in this class that goes up by only small increments. So we see here we start at 0, we go up by 10. Usual guess is that a lot of times they go up by 2s. So 2, 4, 6, 8, 10. See how each of those lines go up by 2? So all you got to do for this is that you just have to show that it goes up by 2 milliliters, each of those lines. Now the next one, I look at the next one and I'm like, oh, okay, I got 10, 20, 30, 40. I only have one minor grid between it. Looks like it's halfway. That's probably going up by half the distance to there. So this is 5 milliliters. Do you guys have any questions about how to do that? Sweet, let's jump down to the more challenging stuff. Let's go to 2. So 2, we actually have to write down the volume that's recorded right here. We have our meniscus. You always measure at the bottom of the meniscus. So the first step is to figure out what the minor grids go up by. So I look, and they look like they go up by 1s to me. I don't know about you guys. Let's take a look. Looks like it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that covers the distance between 10 milliliters and 20 milliliters. So this line is in between 1, 2, it's between 2 and 3. So at minimum, I know my volume is 2 milliliters. I know it's at least 2 milliliters. Do you guys have any questions about that? Now, I'm missing a number because I forgot to write the 10. This isn't starting at 1, this is starting at 10. So I'm actually between 12 and 13 milliliters. Do you guys have any questions about that? All right, now I have to make an estimate. I look at it, and everybody in the class might make a different estimate. It doesn't look quite halfway to me. It looks like, almost halfway. So almost halfway is, to me, 0.4. You might pick something else. That's okay if you pick 0.5. It's okay if you pick 0.3. So this, I'm going to underline it in red. That was my estimate because it didn't fall in between the two. So since that's my estimate, what I'm going to do is I'm going to show my uncertainty. So I'm going to write my units, it's milliliters, plus or minus. And I'm actually pretty uncertain about this. It might be 0.2, it might be 0.6. So I'm going to write 0.2. You guys might have greater certainty. You might be 0.1. All you have to do is record down. You just want to make sure that your uncertainty range covers the probable volumes that it is. Does anyone have any questions about how I made my decision about that? All right, that's how you record your volume. Now there's another thing where you have to practice. What if the volume actually falls on a line? Let's go down to the second row, and I want to look at this third one right here. See this third one? It's the third one to the right on the last row of volumes. See how it actually falls on the line? It looks like almost perfect. All right, so I'm going to figure out what these go up by. It's between 0 and 1, so these must be going up by fractions. So we might be going up by 0.1. 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1. That works. So this is right at 0.3. I know that it looks like it's right at 0.3. But when it's right at 0.3, you still have to make an estimate. So I still have to estimate what this is, because if it was between 0.3 and 0.4, it might be 0.32. It might be 0.35. So what you're going to do is you're going to write a 0, because that's our estimate. Our estimate's 0 because it falls right on the line. So even on a graduated cylinder, if it falls right on the line, you still have to write that extra digit. Then I'm going to write my unit, milliliters. I'm pretty certain that it's on 0.30, so I'm going to write plus or minus 0.01. So notice how my uncertainty, that's in the hundreds place, has to match the place that your estimate was in. My estimate was here, and then my uncertainty has to be here as well. You can write 1 or you can write 2 depending upon how uncertain you are about your measurement. Now, that means that there is no correct answer for recording all of these volumes. You just have to be honest with yourself and be transparent about the number that you're writing down. All right, I want everybody in the class to do, let's do this one right here. Do that last one together with me.